Hello my dears. So from now, from the last class we discussed about the steady state stability and important problems regarding that. On this class also we are focusing on the steady state stability, and it's a very important problem which is already asked in AE examination across India. Okay, across many states in India. So these problems are very important. Okay, even though if you are not that much knowledgeable person about the stability, okay, theory session, okay, leave that, just do this problem and just focus on this problem. You will get a lot of theory sessions you already missed, or you already missed due to lack of interest, etc. Okay, see, some theory problems are there, arrays are, this is not interesting, so you will skip it now. So that important theory sessions also we are explaining here, so it's very important. So please note out all the problems and analyze it and understand it. Okay, you will get a knowledgeable, at the end of the session, no, you will definitely get an idea about how to start a problem. I'm not sure about, okay, if you do this 5 to 6 problem, you will definitely crack every problems in my stability. I won't say that because that's not possible, right? So if you do this, you will definitely get a knowledge, and definitely you can start a problem. You can analyze a problem in stability. Okay, so let's do that. So listen my dear, so a transmission line with a reactance of 0.3 per unit, right? 0.3 per unit is given, is applied at a constant voltage of 1.25 per unit. Okay, it is applying reactive power of 0.4 per unit. Its reactive power is nothing but, my dear, 0.4 per unit, and operating half of the steady state stability limit. Half of the steady state stability limit. The receiving end voltage you have to find. So this is the question, my dear. This is the question. So how can we start with? So for every problems regarding the stability, whether if they are mentioning about the active power or reactive power, the basic equation we have to use is nothing but, my dear, P is equal to EF into Vt divided by Xs sine delta. Okay, and Q is nothing but the reactive power, which is nothing but, my dear, Vt divided by Xs. It's very important. Vt divided by Xs into EF cos del minus Vt. So this is very important relationship. You have to note it down. So this is, let be equation number 1 and let be equation number 2. So this equation regarding the active and reactive power of an alternator. See, that alternator concept now, that alternator having an induced EMF and it having a terminal voltage, that can be extended to the concept of feeder also. The feeder having a starting end voltage, okay, starting end voltage, and after long distance now, the receiving end voltage also there. This starting end voltage and this receiving end voltage will not be same, because due to the transmission line reactance there may be losses in the transmission line, so that the starting end and receiving end power voltages, everything will be different. It is not that much large difference will not be there, but even though there will be an appreciable voltage, a diminishing or voltage, sometimes voltage increasing also, depending upon the power factor correction method we are using. So simply a bare transmission line means there will be definitely a diminishing in the output voltage. Okay, so what we have to find? The operating half of the steady state limit, the receiving end voltage we have to find. That means this end voltage you have to find. So this bus, this feeder also we can consider like a generator or alternator. That means it produces some voltage, let be EF, and it will receive some voltage, that means receiving end voltage will be Vt. So definitely we can apply this reactive power equation in the feeder concept also. That is the main thing you have to note it. Okay, so now my dears, what they are saying, see, for finding whether it is active or whether it is reactive power, we should have a knowledge about del, right? We should have a knowledge about del, that is nothing but the load angle. So how can we find the load angle? For that they are giving operating at a half of the steady state stability limit. We have the steady state stability limit. What is that? P max, na? Steady state stability limit is nothing but P max. P max is nothing but, my dear, EF into Vt divided by Xs. Is it clear? If it is operating half of the steady state limit, means some factor on this full steady state limit multiplied with make it a half steady state limit concept, right? Normally if there is nothing, mean the steady state limit is nothing but EF into VT divided by XS, am I right? It's given that operating at half of the steady state limit means it is not operating at the normal steady state limit. It is operating at half of the steady state limit means something which make it half of the original steady state value. That something is nothing but, my dear, what make it is the half of the original value? The sine delta become 1 by 2. This sine delta become 1 by 2. That makes the active power or the P max to half of the steady state limit. Okay, so from this idea we have sine delta is equal to by 2, or in other words del is equal to 30 degrees. It's very, very important. Okay, for that they are giving half of the steady state limit. That line is given accordingly. Okay, so now you have del is equal to 30. So how can we find the Q? Q is given right now. Q is 0.4, correct? So I can write like 0.4 equal to VT divided by XS. What is VT? VT you have to find, right? That is a receiving end voltage or terminal voltage. You can say anything. Because we already conventionally we are using this equation. That is why for receiving end voltage I took it like VT only. So VT divided by XS. What is XS now? XS is given 0.3. Okay, 0.3 into EF cos del. EF is nothing but 1.25 into cos del 0.86, because cos that is nothing but, my dear, 0.86 minus VT. So only unknown here it is what? VT. Let's do that. 0.4 into 0.3 is nothing but 0.12. Right? 0.3 into 0.4 is 0.12. Okay, which is equal to VT into 1.25 into 0.86. What do you get? 1.25 into 0.86. What do you got? So it is nearly 1.075. So I took it like simply 1 minus VT for simplicity, for simplicity. So it will become, my dears, VT minus VT square minus 1.2 equal to 0, right? VT minus VT square minus 1.2 is equal to 0.12. Not 1.2, it is 0.12. 0.12 equal to 0. So I divide all with the minus, it will become VT square minus VT plus 0.12 equal to 0. If you solve it for VT, what do you get, my dears? If you solve it for VT, you will get, solve for VT, you will get what? VT will be equal to minus B is plus 1 plus or minus root of B square minus 4AC. B square is 1. 4 into 0.12, right? Whole divided by 2, am I right? Whole divided by 2. So it will become simply 1 plus or minus root of 1 minus 0.48, am I right? Divided by 2. Simply 1 plus or minus root of 1 minus 0.48 is nothing but 0.42, whole divided by 2. So simply I should take like 1 plus 0.4 square root is nothing but, my dear, 0.2 divided by 2. So 1.2 divided by 2 is nothing but 0.6, nearly you can say 0.6 per unit. So I can say that this VT will be equal to 0.6 per unit. That is the answer. That is the answer. Okay. So focus on the concept, my dear. This concept is very, very important. Okay. I mean, how we can take the value of del is very, very important. So that's about the question. If you have any doubt, please mention in the comment section. Please mention in the comment section. Okay. Can we do another question? Can we do another question? Okay. Okay, write down next question, my dears. Write down another question. A shunt capacitor is used to use in power system for VAR compensation. VAR compensation is operated at 90-80% of its rated frequency and 95% of rated voltage. Full stop. The work supplied by shunt capacitor supplied by shunt capacitor as compared to its rated capacity by to its rated capacity. See, this is also very beautiful question, my dears. This is also very beautiful question. See, a shunt capacitor is used in power system for the VAR compensation. So we already know that what is the purpose of shunt capacitor in order to produce the in order to compensate for the reactive power by the inductive element, right? That is the purpose of the capacitor shunt. So inductive reactive power is normally lagging in nature, which makes the overall system regulation a poor, right? Regulation will be poor, so that more power will be or more current will be carried out by the transmission line. The active power will not be that much available for the useful working. So we have to use capacitor shunt in order to compensate for the inductive element in the transmission line. So it may be either in series or in parallel depending upon the demand. Okay, another question will be there where you can use a series capacitor. Okay, I will tell that also. So now a shunt compensation is used here and is operating at 98% of the rated frequency, and you see these are very important terms. VAR compensation is operated 98% of the rated frequency and 95% of the rated voltage. The VAR supplied by the shunt capacitor as compared to its rated capacity. That's you have to find. Is it clear, my? So what is the rated capacity of the VAR? I mean volt ampere reactive produced by a capacitor. That we have to find. So normally the reactive power in a capacitor is given by QR is equal to what is that, my dears? V square by XC. Am I right? V square by X is the power. No? So it is nothing but B square divided by 1 by C omega, or simply nothing but V square into C omega. Let be equation number 1. Okay. So that is the rated capacity of the reactive power produced by the capacitor. Okay. So this is nothing but QR. So now you change it to what? Let be QR dash. QR dash you have to find. So what is that? It is not operated at full frequency. It is operating at a 98% of the rated frequency. C is the capacitance and omega is the omega equal to 2 pi of frequency. No, radian per second, right? Omega V square into C into omega, where C is the capacitance, omega is the angular velocity. Okay, you can say, or omega is equal to 2 pi of that also you can say. So QR dash will be equal to C and 95% of the rated voltage, my dear. So the voltage term will be changed like 0.95, right? 0.95 into V the whole square into capacitance will be no change, and omega will be changed like omega equal to what? Omega equal to what, my dear? 2 pi f. So any change in omega also directly affect the any change in frequency directly affect omega, because 2 pi is a constant. So something which is change happen, this the direct reflection will be here in out also. So I can say that 98% of the rated frequency means here also 0.98 into omega happens. Okay, if you multiply these two, you will get 0.95 square into v square into c into 0.98 into omega. You will get like 0.88 c, 0.88 into omega c v square. So this is nothing but qr dash. Okay, so let be equation number 2. So now you got original capacity, that is the original reactive power provided by the capacitor, and also the reduced reactive power also you got, right? Because we have to reduce the voltage and we have to reduce the frequency in the given question. So what happened? The reactive power also reduced because it is directly proportional to voltage square and omega. So whenever you decrease both, definitely the reactive power supplied by the capacitor also reduced. So what will be the change? What will be the change? Change will be equal to what? QR minus QR dash divided by QR into 100. So just nothing but, my dear, 1 minus 0.88 divided by 1 into 100. So it is nothing but, my dears, 0.12 into 100, or simply 12% decrease. So 12% decrease. So that is the change in what? Reactive power. So that is the answer. That is the answer. Okay, the question is actually not that much difficult, but the concept is you have to think a lot, right? Think at the first instance that this formula should be come to your mind, then only this problem can be solved. Okay, in the previous question there is another equation for reactive power. Now we are using another equation for reactive power, right? Both you have to distinguish where you can apply that, where you can apply this. You have an idea. Okay, so that's all about the question. If you have any doubt, you can ask in the comment section. Okay, can we move on to another question? Okay, so the answer will be the var supplied by shunt capacitor will be 12% lesser than the var supplied by the rated capacitance. That's all. Rated capacity. Okay, so that is the answer. Okay, see the next question. Consider two buses connected by an impedance of 0 plus j5 ohm. The bus 1 voltage is under angle 30 and bus 2 voltage is 100 angle 0 volt, and this is also volt. The real and reactive power supplied by bus 1 R. Okay, so this is another important question, my dears. That's another important question. So let's do how can it be solved. Consider two buses connected by an impedance of this much. Okay, the bus 1 voltage is nothing but 100 angle 30. Bus 2 voltage is nothing but 100 angle 0. The real and reactive power, supplied by bus 1 we have to find out. Okay, so before moving to the problem, we have an idea about a rough figure in your mind. Okay, we have an idea of rough figure. So see, consider two buses connected by an impedance. So I am taking like this, my dear. You can create your own rough figure, but we need an answer, that's all. So I am making my rough figure in my own style. Okay, suppose this is generator session, this is one bus, this is another bus. Okay, and these two buses now, these two buses are connected by a transmission line. Okay, sorry, impedance. So in this way directly you can write like one bus and another bus. This is nothing but load section, load side. Okay, so this is nothing but, I will take it like EF angle del, I will take it like VT angle 0. VT angle 0, simply V angle 0 also you can take. V angle 0 also you can take. And the impedance is given by 0 plus J5. This is generator session and that's the load session. See, the figure you can assume in any manner. I assumed it contained two buses. It is connected by a transmission line. I mean reactance of 0 plus J5. Okay, any figure format you can take, but we need an answer, that's all. So I take it in this manner. I take it in this, you can imagine like two parallel buses and connected by anything same now. Anything same. You can say this figure also, you can equally you can say it like what, two buses. Okay, two buses, fine. Connected by a equivalent what? Impedance, right? 0 plus J5. This is also you can take. This is bus 1 and this is bus 2. Any way you can take, my dear. Okay, any way you can take. And see, the real and reactive power supplied by bus 1 you have to calculate. The real and reactive power supplied by bus 1 you have to calculate. So this is also like, see, this is bus 1 and this is bus 2 also you can take, or this figure also you can take, no problem. The thing importantly you have to note is that the real and reactive power supplied by bus 1 means the bus 1 is acting as a supplier of real and reactive power. So what will be bus 2? Bus 2 will be act as the absorber of real and reactive power. That means one bus will be act as a generator bus. Listen, another bus is act as a load bus. That's all. One bus is act as the generator bus, which is nothing but bus 1, and another bus is act as a load bus, that is nothing but bus 2. So one will be in generator bus. So what will be the voltage? I mean voltage format of the generator bus? It is nothing but, my dear, E angle delta format. What will be the voltage format of the load side bus? Which is nothing but, my dear, V angle 0. It is very important. It's very important. So what will be the equation for? So E angle 0 del na, it is directly given like what? The bus 1 voltage is 100 angle 30, correct format, 100 angle 30. So E angle del 100 angle 30, correct. And the bus 2 voltage is 100 angle 0, that also correct. Because we assumed in this format and the given data sources correctly resembles. So you can simply say that it is correct. It is correct. Our assumption is correct. Okay. So what you have to find now? What you have to find now? The real and reactive power supplied by bus 1, which is nothing but, the real power is nothing but, my dear, P. P is equal to what? EF into VT divided by XS into sine del. So simply what? EF is nothing but, my dear, 100. Both have magnitude 100 now. So 100 into 100 divided by XS is nothing but what? You can simply take the magnitude only. Don't go for the angle and for angle like means cases, because just need the magnitude. Okay. Into sine del. Sine delta is nothing but sine 30. So the answer will be nothing but, my dear, 1 by 2. So simply 1000 watt. Simply 1000 watt. So that is the real power supplied by the bus 1. Similarly, reactive power supplied by the bus 1 is nothing but Q is equal to what? Vt divided by Xs into EF cos del minus Vt. So which is nothing but, my dear, Vt is nothing but 100, right? 100 divided by 5 into 100 into cos del, it is nothing but 0.86 minus Vt is nothing but what? 100. Am I correct? So simply it will become 20 into 86 minus 100. So it is nothing but 20 into 86 minus 100 is nothing but 14, right? 14, am I right? Correct, minus 14. So minus 14. Am I right, my dears? So it will become Q is equal to minus 280, right? Minus 280 VAR. So now you got the active power P and the reactive power Q. Q is equal to minus 280 means what? Minus 280. So it is like passive. Power is positive means passive. Power is negative means active. So bus 1 is an active bus, simple. It is giving the reactive power, right? That's why. If it is absorbing the reactive power means what? It will be like positive. Okay, that's all. So that's all about the question. If you have any doubt, you can ask in the comment section. Let me check the time. Okay, time is there. Is it clear, my dears? Is the concept is clear to you? Okay. Can I rub this? Next question. A large power system is represented by Thevenin equivalent. Thevenin equivalent, full stop. The E Thevenin and self Thevenin and set Thevenin are 0.9 angle 0 and 0.25 angle 90 degree per unit. This also in per unit. Everything is in per unit. Respectively, if the shunt capacitor is connected to raise the shunt capacitor is connected to rise the bus voltage to 1 per unit. The MVAR rating of the capacitor bank is assume base MVA 100 and base kVA equal to 138. That's all. So listen, How can we do this? How can we do this? A large power system is represented by Thevenin equivalent. The E Thevenin and Z Thevenin are. E Thevenin is given as 0.9 angle 0 and Z Thevenin is nothing but 0.25 angle 90 respectively. Okay. If the shunt capacitor is connected to raise the bus voltage to 1 per unit, so our terminal voltage will be what? Always 1 per unit. The MVA rating of the capacitor bank, shunt capacitor bank should be, we have to find. The base MVA and base KVA, they are given. How can we solve this? Okay, Thevenin equivalent circuit is nothing but, my dear, any system, any complex system can be represented with a voltage source in series with a what? Resistance or impedance. That is called a Thevenin equivalent circuit. Similarly, the power system also represented like. The power system also represents like a voltage source in series with a impedance. That's all. Z Thevenin. This is nothing but E Thevenin. Okay. So here you are connecting the load. Simple. So there you are using, at the load side you are using what, my dear? At the load side, instead of load we are using a capacitor. At the load side we are using a capacitor. Okay. And this capacitor provides a reactive power in order to compensate for the reactive power in the inductor, so that the overall terminal voltage will be increased to what? 1 angle 0, right? The terminal voltage will be 1 per unit now, so 1 angle 0. E Thevenin will be given by 0.9 angle 0. So you have this side voltage and this side voltage, that is you have EF and you have V. You have EF and you have V and you have that Z Thevenin also. That's Z Thevenin also. So what we have to find? The reactive power produced by the what? The capacitor. So what is the expression for the reactive power, simple reactive power in a transmission line? What will be that? Q is equal to Vt by Xs into F cos del minus Vt. The data are given. Vt is nothing but 1 divided by Xs is nothing but 0.25. Am I right? 0.25. Simply take the magnitude, my dears. EF is nothing but what? EF is 0.9 na? 0.9 cos del. Cos 0 it is nothing. Del it is, luckily we got del as what? 0. See, del as 0. Okay, no need to complicate about del. 0.9 into 1 minus Vt. Vt is what, my dears? Vt is equal to 1. So if you solve this, 1 divided by 0.25 it is nothing but 0.9 minus 1, it is nothing but 0.1. So minus 0.1. So minus 0.4 per unit will be the reactive power. That is the reactive power not due to the capacitance, my dear. That is the reactive power due to up to this, a voltage source and a reactance, Z Thevenin. Due to that we will get what? We will get a reactive power. Okay, and the terminal voltage 1 angle 0. And how can you reach to this 1 angle 0? By adding a capacitor. So the capacitor should provide what? This much reactive power in phase opposition to the reactive power in the inductive effect. See, this is nothing but due to the inductive effect, because Z Thevenin is taken by 0.25 angle 90 degree now. So this is due to the inductive effect. So this much reactive power, this is not, see, this much reactive power you should supply in the what, transmission line, so that the reactive power produced by this will cancel the reactive power produced by the capacitor. Okay, so now it is given like a minus 0.4 per unit. So in MVA, Q in MVA R equal to what? It will be equal to what? Minus 0.4 into 100 MVA na? So minus 400 MVA, MVAR. Minus 400 MVAR. Correct. Is there any problem? No. So minus 400 MVAR should be the reactive power supplied by the what? Supplied by the normal reactive power in the transmission line. So a capacitor should be added. And that should be 0.4 into 100 minus, it is simply 40, my dear, 40. That's there I confuse a little bit. It's okay. So minus 0.4 into 100 is nothing but 40 MVAR. So we have to write like the MVAR supplied by the capacitor is, this is the reactive power in the transmission line. So opposite to that same power will be supplied by the capacitor. So it will be plus 40 MVAR. Is it clear? It is minus 40 MVAR now. So opposite should be supplied by the capacitor. That is nothing but the 40 MVAR. 40 MVAR should be supplied with the capacitor, or the capacitor should to compensate for this much reactive power. Okay, or in other words, the capacitor should provide this much reactive power. Then only the system will be compensate for that inductive effect and make the voltage to 1 angle 0. I mean the angle is 0, my dear. Angle is 0 means there will not be any load angle. So that should be compensated. That is the meaning. So that's the answer for the question. That is the answer for the question. Okay. Can we move to another question? Can we move to another question? Okay, is it clear? Is it clear? Okay. Can we do another question? Listen. Given that maximum power transmitted through a line is Pmax, comma. Then with the 60% of series capacitor compensation, the maximum power transfer become maximum power transfer becomes. This is also an interesting question, my dear. That also we have to do. That also you have to do. See, how can we solve this? How can we solve for such question? How can we solve for such question? See, given that the maximum power transmission to a transmission line is Pmax, so what is the equation for Pmax, my dear? The maximum power transferred to the transmission line is nothing but its stability, steady state limit, right? We have P is equal to EF into Vt divided by X into sine delta. So maximum value is nothing but EF into Vt divided by X. So that is nothing but the Pmax. So we have Pmax is nothing but EF into Vt divided by X, or simply Xs. Okay. Now, with the 60% of series compensation, now see, my dear, this Xs is nothing but the synchronous or simply the reactance of the transmission line or the reactance of the total system, where the power start to where the power receive, that's all. So this is predominantly what? This is predominantly inductive. Predominantly inductive. So what we are doing, my dears, we are adding a capacitor in series with the transmission line so that its capacity is nothing but 60%. It's only 60% of compensation is given. That means if you provide exactly 100% of the compensation here, the power transfer will be this. May suppose you add excess. Normally excess now. If you add equal value of capacitance having reactance of same excess in opposition to this one, then excess minus excess will be what? 0. So the power P max will be infinity. That's not, it's an ideal case. We can't create that. We can't create that because there is another factor which is nothing but the frequency that will never mismatch, or in case that mismatch mean it will deviate from the power transfer frequency, that is 50 Hertz. So that will never happen. So what we are going to do, we are going a 60% compensation, which means normally EF into VT divided by XS now. So what we have to do, let be P dash max is equal to EF into VT divided by XS minus 60 divided by 100 into XS. That much you can provide. If you provide simply XS as phase opposition to the inductor, it will become XS minus XS. I already told you the problem. So you can, they are doing what 60% compensation means, XS minus 60% of XS in phase opposition we are adding. Is it clear? So what will become? It will become EF into VT divided by, suppose I am taking XS as outside, it will become 1 minus 60 divided by 100. So it's simply nothing but, my dears, EF into VT divided by XS into 60 minus 100 minus 60 is nothing but 40 by 100. Am I right? It is nothing but, my dear. What is this EF into VT divided by XS? We have P max. So it is nothing, P max divided by 40 by 100 is nothing but, my dear, 0.4. So that is the final answer. So P dash max will be equal to P max by 0.4. P max by 0.4, you will get some value. So that will be the final answer. That will be the final answer. Is it clear? So the maximum power transfer now become P max by 0.4. These all are very, very superb conceptual question, my dear. Superb conceptual question. Unless you do it at least once before the examination, you never crack it. You never crack it. I'm not saying not for all students. Brilliant students are there. You can imagine and you will carry. I'm talking about normal students like me. Okay. If I didn't do at least once in this before examination, I can't do that because in this way I can't think. I can't think. Okay. So only by doing at least once. Okay. This way also you can think. That idea I got from that. Okay. That's I am sharing with you. Is it clear, my dear? Is it clear? You have any doubt? You have any doubt? You have any doubt? Can we do another question? What's the time now? Okay, time is there. Can we do another question? A 40 MVA, 11 kV, 3 phase, 50 Hertz, 4 pole, turbo alternator has an inertia constant of constant of 15 seconds. An input of 20 megawatt developed. Input of 20 megawatt developed. 15 megawatt of output power. Megawatt of output power, neglecting losses. Then the acceleration is and the acceleration is. How can we do this, my dear? How can we do this? Inertia constant means suddenly you should take one equation should bring to your mind. That equation is nothing but swing equation. Okay, so we have the basic swing equation as dm into d square del by dt square equal to pm minus p. Okay, which is nothing but the acceleration power, pa. Pm is nothing but the mechanical power and P is nothing but the electrical power. Under balanced condition, this Pm will be, that is the input power, or simply this is the input or this is the output power. That also you can take. Is it clear? So, M is, you have to find M. This 40 MVA is nothing but the rating of the machine, my dear. So, M is nothing but, my dear, M is equal to GH divided by 180 to F in electrical degree. So it is nothing but G is nothing but 40 into H is nothing but 5 divided by 180 into 50. A 50 hertz transmission line, they are given, right? Is it clear now? It is given. So what will be the answer? 10, 4. So it will be 1 by 45. Okay. What is the unit? It's actually megajoule seconds per radian, right? Megajoule second per radian. So applying this equation, 1 by 45 into d square del by dt square is equal to Pm, or simply the input power. Input power in electrical, it is directly given 20. So 20 minus 15 is nothing but 5. Correct? We missed something. 40 into 5 divided by 180 into 50. So 5 and 5 10 and then 4. 4 means 45. 1 by 45. Am I right, my dears? 15 minus 10 minus 15 is correct now? Yes. 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 120 into F. Yes, smaller where, but smaller came. Okay, 15 second now. 15, not 5, my dears. It's 15. Yes, they are the problem. Okay. I took it directly 5 now. It is 15. 15 second now. Inertia constant H. So it will be 15. So these things will not work. So 14, 15. I'm cut it with 5. So 5 into 3. 5, it's 10. Okay. So I can cut it with 60. So 1 and 1 gone, sir. So it will become 4 by 16 or 2 by 13 or 1 by 15. Correct, na? 1 by 15. Am I right? Am I right, my dear? Correct. So it will become 1 by 15. So d square del by dt square, it is nothing but what? D square del by dt square, double differentiation of angle. Del is angle na. Double differentiation of angle will give you the acceleration, which is nothing but, my dear, 15 into 5, 75 meter per second square na, normally. So instead of meter, it is in angle, degree na. So degree per second square. So 75 degree per second square. And I want to mention one more thing. Concept of critical clearing time and critical clearing angle. Okay, is it over? You wrote it? I mean, you noted it? Okay. I want to mention something. So critical clearing angle del C. So critical clearing angle del C is nothing but, my dear, I already told you now, it is the maximal angle below which you should clear the fault. That means, suppose some fault occur, the rotor angle will be increasing, right? The rotor angle will increase. So up to what rotor angle you can allow the rotor to increase its angle? Up to what angle you can allow to accelerate your rotor so that the del will be increasing and increasing and increasing. So up to a particular value only you can allow this increment. You should clear the fault before that particular value. If you do not clear the fault before that particular value, the machine, even though you've cleared the fault, my dears, the machine will not come to synchronism. The machine will not operate in synchronism. The machine will lose its synchronization capacity. That angle is called the critical clearing angle. And critical clearing time is also there. Time is also there. There is an equation also, Tc is equal to root of (2m) divided by Pa into, this is nothing but accelerating power. M is, you know this now, moment of inertia. This is critical clearing angle, and this is nothing but initial load angle. Initial load angle. Okay, so this equation is very important, my dear. Normally this equation, directly you can expect this equation in examination. They will not ask about these very problems regarding these things, critical clearing angle and critical clearing time, but this critical clearing time equation is very important. 2m divided by Pa into del C minus del 0. The del T is a critical clearing angle, del 0 is the initial load angle. So critical clearing time is nothing but the time required to clear the fault so that the machine will not lose its synchronization. The maximum time, critical clearing time is defined in this way. It is the maximum time required to clear the fault before the machine losing synchronism. That's all. Or if you clear the fault after this TC, critical clearing time, then that machine will definitely lose synchronism. You can't bring back your machine to synchronism. It should be isolated permanently. Is it clear? So that is the concept, my dear. So by this I am going to wind up this power session. The last few classes in the power session, this is advanced power session, power system. So those who are preparing for AE and assistant inspector is already gone now. Assistant professor examination, definitely go through this. Question will be asked from this because the exam will be into that level. So for those who are preparing for sub-engineer, let me wait for until the syllabus come, so that then only we can say that the stability session is there or not. Okay. So but my wiseful advice is that don't give up this, you study. Okay, whenever the syllabus come, if you don't want, simply omit that, simple. But if there is stability in the syllabus, then you are lucky now, you already studied. Simply you have to refresh one thing in time. Until now there is no dates and all announced, right? So you have enough time. So please go through this, study once more, make your own note. Definitely these things will be utilized at anywhere you can't predict. Okay, so that's all for today, my dears. So let's meet again with very new topics tomorrow. So until then, bye, take care.